All right, so this is a piecewise. We're still struggling a little bit with piecewise. It looked yesterday mainly like the graphing portion. The domain and range you seem to be getting it a little bit better. We'll see. All right, I've got if x is less than or equal to 3. I've got x if x is between 3 and 5 exclusive, and then -1 if x is greater than or equal to 5. So I'm going to just take these one piece at a time. First thing I'm going to do is plug in the 3 here. So if I plug in 3, I got -3 times 3, which is -9, plus 7 would be -2. Is it closed or open there? Closed. Closed because of the line under it. And so several of you have said, how do you know the direction that you go in? How do you know where the arrow goes? So this is my starting point, and it's always my starting point. I always start with the point that I plug in first. It's listed there. Now I'm going to do an x that's smaller than 3. So maybe what? 2 times -3 is -6, and -6 plus 7 is 1. This one doesn't get a closed or an open. It's always just a point on the line, so it's always closed. And that's the direction that it's going to go. Y'all all look at it? Ah! Sorry, it's 2. Sorry, like that. There you go. Sorry. And then when it's x, I'm just going to plug in these 2 endpoints, and then those 2 points are going to connect with open dots because there's no line under here. So I have 3, 3, and 5, 5. So 3, 3, and 5, 5. They're going to come together something like that. And then the very last one is just a horizontal line at -1, but it starts at 5. So I'll start at 5, -1, 5, -1, and it is a closed dot. If I pick an x bigger, I might get 6, -1, but it's going to go this way. What's wrong? You want it to be bigger than 5, not smaller than 5. What's the domain? Which one are you looking at? This one? Yes. So I plugged in 5 for x. But if I plug in 5 for x, it doesn't matter what I plug in for x, I'm going to get -1 back out, right? Well, because it says that x has got to be bigger than 5. Where are we confused? I want to make sure I answer your questions. I don't want to. Don't be scared to ask. You multiplied them together. So if this was -1x, that's what you would do. But because there's no x in it, it's just a number. It says that no matter what x is, y is always going to be -1. Anytime it's just a number without a variable, that's what that means. Caroline, did you see why it's bigger, not smaller? So it's eating the x, which means I want x, whatever I plug in for x, to be bigger than 5. What's the domain here? Okay, so if you're looking at this, you might think that it stops at 3 because of this. But as I go up, there's another piece of graph here left to right, right? And then there's another piece of graph that picks up. So it's actually -infinity to infinity. So as you move left to right, so I'm moving across, This is still going left, right? And it kind of ends right here. But that point is included, and if I come straight up, there's another piece of graph that picks up there. So then it keeps moving left, and this piece of graph ends, but this one picks up exactly where it ends, and it keeps going forever right. So left to right, I don't have any, I'm not missing any graph. Now from the bottom up, I just might be, what's the lowest the graph ever goes? -2. We all see that? That's the lowest point on the graph. It can be -2, so I do a bracket. And then as I move up, well, this piece alone right here will go up forever. So it's going to go up to infinity. Any other questions? Yes. Number 12 is your greatest integer function. That's the only one that was the new material yesterday. F of x equals 2x. So remember, I need to find that jump. So maybe I start with my same 0 and 1 that I normally start with, right? If I plug in 0, I get 0 minus 3, which is -3, right? So 0, 1, 2, 3. If I plug in 1, I get 2 minus 3, which is -1. So I get 1, -1. So now my question is, where is it jumping? So let's go halfway between those and see, make sure that I find the place where it's jumping. So if I plug in a half, 2 times 1/2 is what? 1. Uh-oh. And 1 minus 3 is 1 minus 3? -2. All right, so I'm at 1/2, but I'm down to -2. If it's a decimal or a fraction, you jump down. If it's already an integer, you keep the integer. I've got to find a number where it is a decimal so I can tell, I can make sure where it's jumping, right? What if it jumps again in between here? So let's see. Let's try maybe, what's half of a half? 1/4. Let's try 1/4 and see what happens. If I plug 1/4 in here, I have 2 times a fourth minus 3. So that's 1/2 minus 3, which is what? -2.5, right? Are y'all following me on that? So if I'm at -2.5 here, and I got to jump down, that puts me at -3. So halfway between here, I'm still down at -3. So it looks like what's happening is it's jumping at the halfway marks each time. So all the way up to a half, and it's not, they're half as long as what they were. Does that make sense? And if you look back at your notes on number 6, that very last one we did, it had a 1/2 in front, and that made it twice as long, remember? So this 2 in front made it half as long. It did the opposite of what it seems like it would do. Does that make sense? See how we got it? Anything else? Oh, domain. Right? The range is integers, the set of all integers. So what I generally do is I start with 0 and 1, and I look to see. And if I have different values for 0 and 1, I'll go halfway in between 0 and 1. But if I get the same value there, I know it's not jumping there. So maybe I need to go to 2 and see if it's jumping somewhere in between there. I'm trying to find a place where I get different values so I know it's jumped, and then I try to narrow it down to where it's jumping. Y'all okay? Y'all ready for some absolute value? Yeah! Come on, y'all. Smile at least. Oh my goodness. All right. Do y'all need a break in between? We kind of didn't start until late. Aiden, are you good back there? You sure? Function again means one and only one output for every input, right? Every x only has one y. These are a lot easier than the step functions. I think you'll like them a little better. And you should have seen them before. Have y'all seen them before, the graphs, what they look like? These are the ones that come together and they look like a V. All right. What does absolute value do to a number? It makes it positive. That's the only thing it does. Whatever it is, it makes it positive. If it's already positive, it stays the same. If it's negative, then it changes it to positive. What does the absolute value sign look like? 2 lines. That's exactly right. So the absolute value function looks like this. That means the absolute value of x. This would be our parent function. That's the one we're going to graph first right here on your very front page. We're going to run through those values and see what happens and what it looks like. Talk about the domain and range on it, and then we'll talk about some ones that are stretched and shrunk and shifted and look a little different. So we've got -3, -2, -1, 0, 1, 2, and 3. I'm graphing this absolute value of x right here. And we said that the only thing absolute value does is force it to be positive, right? So, what's my y value going to be if x is -3? Right? What forces it to be positive? That's not hard, right? All right, graph them. See what happens. Whoa. Okay. So, essentially what this is, and we could graph this, the reason this is included kind of with piecewise is it's really two pieces of the same line, but if you think about the line y equals x, right? The line y equals x looks like this. The absolute value just takes this negative part and flips it up here. That's why it looks like a V. Okay, so everything that was negative becomes positive, and that's why it looks that way. So it does look like a V. And the turning point, or this bottom point right here, any ideas what that might be called? The vertex. Whoa. This is called the vertex. Just like, it looks very similar to a parabola. The only difference is instead of curving into it, it's a straight cutoff right there, and it forms a very sharp point at the V. All right. Y'all ready to graph some that aren't at 0, 0? So what we're going to do as we graph these, oh, we got to do domain range, don't we? Sorry. How about domain? All of these will be negative infinity to infinity for the domain. This domain and range should be a whole lot easier for you than the piecewise graphs. How about the range? 0 to infinity. Should I do a bracket or a parenthesis on the 0? I heard both. I'm going to do a bracket. Why am I doing a bracket? That point is bubbled in. It includes it. It is the vertex, and it is part of the graph. That's a very important part of the graph. Y'all okay? What happens if my vertex is not 0, 0? If I have something, an equation that looks something like, this is number 1, something like this. The first thing I want to do is find the vertex. Okay. So how in the world am I going to find the vertex? Now, this is going to be a little bit different than what's written on your paper here. If you want to do it the way that she's got on here, you're more than welcome to. It works also. This way is a little bit less work than what's on here. The vertex, if I have this equation, I'm going to put this A out front because we always have this little naggy A out there. I'm going to use some variables that look very familiar to you. Yes, yes. That looks like vertex form, right? Let me make sure this is gonna. I don't know if I want to teach you like this because this is getting into transformations. We'll do it like, don't write this yet. If you did, erase it. Let's do it basic way first. I normally only teach absolute value with transformations. It's hard for me to teach it with a T-chart. Let's find the vertex though. Let's just follow the steps that are on your sheet, and that way you already have the notes. So set what's in the absolute value equal to 0 and solve for x. Okay, and this is written in step 1 right here in your paper. You don't even have to write it again. So if I'm looking at this example, I'm talking about x minus 4 equals 0. So what does x equal? 4. So if I'm on my T-chart, whoa. I definitely want to start with 4. I think that that's my vertex. And what I want to do is I want to pick 2 numbers above and 2 numbers below. Because remember how it V's? So I want enough to go in either direction. So I'll do 3 and 2, and then I'll do 5 and 6. If you're OCD about how your numbers are written and want them in order, you can line them up if you want to put the 4 in the middle and then go whichever way. You certainly may. It doesn't bother me, so, but whichever way you want to do it. So let's plug in. If x is 4, what is y? What is it? 4 minus 4, and the absolute value of 0 is, how about 3 minus 4? -1, and so then it gives me +1 because it's the absolute value. How about 2? 2, 5, 6. Let's graph it. No closed or open dots. Everything is just regular old points on here. So start with 4, 0. Now I'm going to go 3, 1, 2, 2, 5, 1, 6. These what? Oh, you wasn't talking to me? Well, excuse me. Does this make sense how we did that? What's the domain? Nobody should miss the domain on any of these. How about the range? Exactly the same. Not for the range, no. But for the domain, yes. From the bottom up. What's the very lowest point on the graph? 0. And then it goes up forever. Let's do number 4. Oh, that's what everybody was. I was wondering what I was like. What is wrong with y'all? Why is everybody acting so funny? There's 2 number 4s. Look at the second. It's really number 6. Yeah. On the back of the first page. Do y'all see it? It's in the middle of the right column. Everybody with me? All right, let's find the vertex first. What do I need to do? 0. Set it to 0. That's right. Set just what's in these parentheses. Just what is in those brackets. My gracious, I cannot talk. Just what's in the brackets to 0. So 1/2 x plus 1 equals 0. What do I do first to solve that for x? Subtract the 1. That's exactly right. So I have 1/2 x equals -1. Uh-oh. I have this fraction. How do I get rid of it? Multiply by what? Y'all are exactly right. Multiply by the reciprocal. I'm going to multiply by 2 to get rid of it. I don't ever want to divide by a fraction. I'll always multiply by the reciprocal. Instead, it makes my life a whole lot easier. Look at the back of the very first page we were on. Close the packet. Look at them. No, okay, right there. You see it in the middle of the right-hand column? Yeah. All right. Do we all agree we're at -2? And do we see why? Okay. Let's do our table. I've got -2, and I need to go 2 places in either direction. Give me the numbers that I need. -1 and 0. We all okay there? We all see where this came. A lot easier than those step functions yesterday, right? A little breath of fresh air. Not quite as hard. All right, so let's plug them in and see what happens. These you might have to write down a little bit with that 1/2 that's in there. It might start giving you a little trouble. -2 times 1/2. -1. -1 plus 1. And 0 minus 4. Okay, so you only take the positive value of what's in the absolute value brackets. Okay, so I take the positive of this and then I subtract 4. Okay, so that 4 is not in the absolute values, so I keep that value. Say that one more time. Yes, yes. So think about those brackets like parentheses. They're grouping that together. So do that first. Take the positive of it and then do anything else that's outside of it. Right, yes. All right, how about -3? What'd you get? In the, oh, all together. All right, so when you plugged it in, you got negative, or you got 1/2 times -3 plus 1, right? This is what's in the parentheses first. This is -3/2 plus 1, which is -1/2, right? This is -1.5 plus 1, which turns into +1/2. And now remember, I have to subtract 4 from that. So that's how I get the -3.5. Because you left that negative, you've got to turn it positive because it's an absolute value. No, +1/2. That's where you're messing up. So see, if it's in these brackets, that means you have to force it positive. All right, you try -4, see what you get. Good, that's right. Yes, the end answer can be negative. The only thing that can't be negative is what's inside those absolute values. Now if I plug -1 in for x, what do you get? Do you see the pattern that's going on here? You should get -4 for 0 if you plug it in. Oh, no, I lied. -3, sorry. But remember, they're the same on either side, right? Because that's what absolute value looks like. So now as I graph this, I have -2, -4. This should be my vertex because I started with my vertex. And maybe I'll even put a V so I remember that that's supposed to be my vertex. -3, -3.5, -4, -3, -1, -3.5, and 0. Oh, my thing's got all out of whack here. Something like that. We'll probably just finish this one page. Probably won't get to inequalities. Well, what time do we get out of here today? What's the domain here? What's the range? I do want to just show you, because we won't test this very heavily, but I want to show you how the inequalities make a difference on the next page. If this, instead of equaled, had been, let's see, hey, you know what? It flips at the vertex. We'll stop here. I'm not going to go into inequalities. We're going to stop here. But whatever that starting point, when you set that middle equal to 0, right? This is the point where it flips. That's your V. That's your sharp point at the bottom. Yes, just do up through number 8. Now 7 and 8 are going to be hard for you because those are piecewise with absolute value. I know. But try those. I'm sure we'll have to talk about them tomorrow. Just go all the way through that very first page and we'll pick up the next part tomorrow.